Welcome to you all here at the Milky Way Galaxy. Me and this cat, we're going to teach you a few things about gravity and galaxy. Many people do not realize the scale of this problem. Newton's law of gravity appears not to work for galaxies. But the issue is made worse due to basic errors in the question. The rotation speed of orbits should be highest near the center. This is why Mercury was given its name. It moves fastest because it is nearest the Sun, where the mass is concentrated. It makes no sense to expect the velocity to be less at the center, if this is where the force of gravity is highest. If most of the mass is at the outer rim, then there could be no consistent body at the center. Everything gets pulled away from the middle that ventures there. Thus, it is abundantly clear that spiral galaxies consist of a supermassive binary pair because velocity is lowest near the center. So I developed OG4, which is Orbit Game 4, to see how this gravity dynamic evolves. The algorithm works by stars being emitted from a binary pair of white holes. I call them white holes because they emit mass. Stars, or pre-solar masses, are ejected at the equator of the white holes because of excessive spin, which overcomes gravity. The pre-solar mass is itself spinning, and this is why it pulls apart and often forms a binary pair of stars itself. This also answers the question, why do all stellar objects spin, and why most stars are binary pairs? As you can clearly see, this dynamic must result in a pair of spiral arms forming. Stars ejected at the highest speed have often reached escape velocity. This is one reason why the higher rotation curves are near the outer rim. The stars do not really form classical orbits, but instead spiral outwards. At the end of their lives they go dark and cause a halo of unshining matter around the galaxy. This can easily be seen when the galaxy is viewed edge on. This image shows the obvious positions of the two centers of mass. Can you see how the one arm is pulled back by the larger white hole? But why is so much light coming from the center? Let us run the OG4 algorithm again, this time with a bit less random. The user can adjust the variables a bit here. The beauty of it is that Newton's law of gravity is hardly altered. The only change is the use of Max Planck's quantum time, which affects gravity itself very little, other than to allow for the computation of numerous interacting gravity fields. Quantum time also perfectly accounts for the gravity assist. Details of that can be found under the heading Quantum Gravity on the Flight Light and Spin homepage. Of course, this model does not show the expansion of the universe, but at an earlier stage, the binary pair of white holes would be closer together. So stars emitted in the earlier phases are also likely to be pulled by a greater force from the opposing white hole soon after ejection. This is another reason why older stars at the outer rim can have higher velocity. Even tiny differences to starting velocity will result in some stars falling inwards. At the dead center there are ferocious collisions between stars, which emit stupendous amounts of light and energy in a series of cataclysmic events. This explains sudden bursts of energy that have been detected coming from the center of our galaxy. Of course, the computer can only calculate about 200 stars at a reasonable pace. But that does not affect the structural principle on display. The reason why I start the star's life quite far from the source is in order to speed up the process while keeping a fairly low error margin. If I started the stars right at the edge of the white hole, then the algorithm would need to run much more slowly to avoid the large error margins caused by computational quantum time. This is the only theory I have heard of that attempts to explain why galaxies have a clear binary structure with distinct duality in the arms. Even when there are multiple arms, they all come from two sources. We can see how this evolves in the model, with older parts of the arms further out, and newer arms more distinct and closer in. This thesis also explains why spiral galaxies are flat, whereas the non-spiral fuzzy or elliptical galaxies do not have any known problems with the speed of the rotation of their stars. So how do these boring-looking galaxies form? Due to the amalgamation of spiral galaxies, where the result here can only eventually be a single body at the center, all spiral structure being lost in the merger. Some galaxies also have an oscillation in their rotation curves, so that at various distances from the center, the speed is alternatively faster and then slower. This will occur when the binary pair of white holes are in an eccentric orbit. It is also vital to see that we can only properly ascertain the velocity of the stars in galaxies when we view the galaxy edge-on. In a top-down view, there can be no observed difference in the Doppler effect. So how does the binary structure of the galaxy itself begin? For that, see the video called The Big Unwind. The Big Unwind. The Big Unwind. The Big